Hello and welcome to another comparison between Python and R for data analytics. Today we're going to look at artificial neural networks, which are a way to mimic the human brain with computer algorithms. Some real-world applications are image recognition, autonomous driving, and everything where we basically want the computer to make a rational decision. How does an artificial neural network look like? We have different layers of interconnected nodes that resemble human neurons and going to create an output after consolidating the hidden layers into an output layer. A single node receives different inputs with specific weights, and based on an activation function, it's determined whether or not the single node is going to pass on its information to the other nodes it's connected with in the network. How does this look with code? We're going to look at Python and R code and try to determine which one is the best for this specific technique. First, we're going to load the libraries in both languages. You see there's no big difference. And we're going to import the dataset. First in R and then also in Python. Our data is 85 categorical input variables that basically predict if an ad is clicked or not. So we're going to use 80% of the data to train our model and 20% to test our model. Again, splitting it up looks pretty similar in Python and R, and we see we have about 4,500 lines of data to train our model and about 1,200 to test it. Artificial neural networks work best if they get data that ranges from 0 to 1, so we're going to scale our data to fit that. Again, on both sides the code is pretty similar, and we're going to also separate the predictors, the 85 input values, from the last column of the data set, which predicts if an ad is clicked or not. Now let's get to the interesting part and look how we built the artificial neural network. In both languages we use the Keras library, which is the most popular artificial neural network library. It's built upon Google's Python TensorFlow library and lets us create a sequential neural network pretty easily. So we're going to run this and look at the model summary on both of these. Takes a little longer in R, but that's fine. The biggest or the most interesting part is when we train the model. Let's look at Python first and then run the same command in R and see what happens. In Python we get output that kind of like gives us information about how the model is trained and how accurate it is. After 10 epochs, which means 10 times through the data set and training the model, we get this output that shows about an accuracy of 94%. What about R? We run the same command and we see no output at all, because R actually builds upon the Python TensorFlow library and only provides an interface to it through the R language. So we do not get any output. The output would be in a Python console, but the Jupyter notebook only provides the R console. Let's look at the results. Here we see R strength, only one command, and we get a very nice chart that shows the history of training the model. The same thing in Python takes a little more code, and we actually see that our model is about 94% accurate, at the training data and then also the test data. We see a little bit of overfitting here in the end, so we might cut our model short after 8 epochs. Let's see what our actual error rate is and our accuracy. And we see with only a couple lines of code, we get a statistical model that predicts the right outcome in 93.99% of cases in Python and 94.1% in R. But keep in mind, both of these results are created by a Python backend. So it's only about 0.02% difference, which is just which is statistically insignificant. So let's look at our score, and we actually see that we found, well, our biggest strength is the very simple output of a very nice diagram that shows us the history. But that's about it. After code volume and ease of use, which we found R to be better in, we see that Python's gonna dominate in the rest of our categories. Well, to build the artificial neural network, R's package relies on a Python backend. So basically, any issues related to TensorFlow, you rely on a Python community. And since R only provides an interface, and we use TensorFlow as the metric, and Python is growing more rapidly in terms of artificial neural networks, and TensorFlow is backed by Google, so the quality is ensured, and it's very popular too. In terms of performance, we have the same performance because both techniques use an underlying R TensorFlow library, but we don't get any console output with R because it doesn't display any Python console messages to the R Jupyter notebook, and therefore Python also wins in this category. If you want to export your model after you have trained it and use it somewhere else, you're gonna use a Python array to export it. And also, if you want to scale it out or basically train a bigger data set, you're always gonna be falling back on Python because TensorFlow is only a Python library and not available in just written in R. The same thing holds true for training and support. All issues with TensorFlow are going to be Python issues, and you're going to rely on the Python community to give you answers. Overall, both techniques are very easy for beginners to get an introduction to artificial networks, and they're the same interface to a Python network, to a Python library, and therefore they're going to get the same scores. However, overall, if you want to use a language to build artificial neural networks, Python is your go-to. It has many popular and very powerful libraries such as TensorFlow that's supported by Google, and it's on the front of innovation and the language you want to use if you want to work with artificial networks. R provides an interface to very popular libraries, but itself is lacking behind, and there's no really R native libraries that let you create artificial networks in an easy manner. Thank you for watching this, and I hope this helped you a little bit in order to make a decision if you should learn Python or R for data analytics.